Given, the root of a binary tree, node values are integers. Return, the maximum path length among all Univalue paths in the tree, count edges on the path. Example 1, the tree has 3 nodes labeled 5 along the root, its right child, and that child's right child. They form one straight Univalue chain. 3 nodes means 2 edges between them, so the longest Univalue path has length 2. Example 2, the left subtree is a column of 3 4s. That is again 3 nodes on one value, so 2 edges. The answer is still 2. Imagine we are building a chain. You can only link 2 nodes together if they share the same color or value. If the values do not match, the chain breaks instantly, and the path length at that junction becomes 0. Every node in the tree is a potential intersection. If both children match the parent's value, we can combine the left chain and the right chain to form one long path through that node. This combined length is what we check against our global record. Here is the catch: a node can use both its arms to calculate a path through itself, but it can only offer its strongest arm to its parent. We return the maximum of the left or right branch to keep the path a single, continuous line. We work from the ground up. By the time we reach a node, we already know the longest matching chain starting from its children. We just check if the parent matches those children, add 1 to the count if it does, and keep track of the biggest number we ever see. The chain is only as strong as its next link. Even if a child has a path of 100 nodes below it, if that child does not match the parent, the connection is severed. We reset that branch's contribution to 0 and start fresh. One global tally, best, tracks the longest same value path we have seen anywhere. It starts at 0. A null child is an empty branch, the recursive call returns 0, no edges to add. First post-order visit is the deeper left 4, a leaf. Child DFS values are 0, no matching children to extend, so we return 0. The deeper right 4 is symmetric, zeros in, no arms, return 0. At the upper 4 in the left column, both children match 4, so each arm becomes 1. The through path at this hub uses 2 edges, so best becomes 2. Next is the leaf 5 under the right 5. Again zeros on both sides, return 0. At the right child 5 of the root, only the left child matches, so one arm is 1 and the other is 0. Best stays 2, and we return 1 upward. Finally at the root 1, the child strands are 1 each but the values do not match, so both arms reset to 0. The global answer stays 2 from the left subtree. Remember we only pass max of left arm and right arm to the parent, never the sum, so the upward strand stays a simple path. Time is linear in n because one post-order pass visits each node once. Space is order h for the recursion stack, where h is tree height, a skewed chain gives h equal to n. One shared integer best tracks the longest Univalue path in edges, every DFS call reads and writes it. Public entry, given the tree root, return that best length. Reset best to 0 before the walk. Start depth first search from the root. Return best to the caller. DFS visits one node and updates the global best when a longer through path appears. If the node is null, there is no subtree below. Return 0 because no edges extend from null. Read the node value into V for comparisons below. Recurse on the left subtree. Recurse on the right subtree. Lu starts at 0 for the matching left arm through this node. RU starts at 0 for the matching right arm. If the left child exists and matches V, extend the left arm by 1 edge. Set Lu to L+1 for that matching link. If the right child exists and matches V, extend the right arm by one edge. Set RU to R+1 for that matching link. Update global best with the throughpath LU plus RU at this hub. Return only the better single arm so the parent keeps a simple path.